Hi, so today I'm going to go over 5.2, which is direct variation. I'm going to skip the do now because this was from a previous section. I'm going to start here. So direct variation is very similar to slope-intercept form, y equals mx plus b. The only difference is that the y-intercept here is 0. So every graph will start at the origin at 0. You can copy down the words. It's a relationship in which the ratio of y to x is a constant m. Y varies directly with x. So here are some examples. We have y equals 2x, y equals x, y equals 3x. You'll notice that all of them start at the origin. The very first point that you would plot is right here at 0. Okay, and then you can see each one's a little bit different depending on the slope. The slope changes the steepness of the line. The least steep is the green one because the slope is 1 or 1 over 1. Then next is 2 over 1, up 2 and over 1. And then the steepest line is 3. So the larger the number, the steeper the line. Okay, so identifying a direct variation equation. Basically, you have to get each equation into this format. And if you see a plus b other than 0, it is not direct variation. So looking at number 1, it's already in this format, y equals mx. And there is no plus b, therefore the y-intercept is 0. And this is a direct variation. Number 2, it's already in that format, y equals mx, but you can see that the plus b is something other than 0, it's 2. So this is not a direct variation equation. Number 3, we want to get it in this format, so in order to get it to say y equals, I need to get rid of the 7, so I will be dividing by 7 on both sides, so that the 7 crosses out and I get y equals 2 over 7x. Once it's in that format, I could see that the y-intercept is 0. Therefore, this is a direct variation. Now you're going to notice a pattern when there's no numbers by themselves. It usually is a direct variation. For example, in number 2, right here, there's a number by itself, that plus 2. That makes it not a direct variation. In number 3, the 7 is attached to the y and the 2 is attached to the x. So there's no number by itself. Therefore, it is a direct variation. Number 4, right, if I subtract 4x, because I want to get y by itself, I get 5y equals. Now I can write 0 minus 4x, but I actually want to write just negative 4x, because I don't need to put that 0 there. My last step will be to divide by 5. I will get y equals negative 4/5 x. I don't have, well, my y-intercept is 0, so yes, this is a direct variation. Alright, moving on, part 2, writing a direct variation equation. So suppose y varies directly with x, and y equals 35 and x equals 5. What is the direct variation equation? Okay, so in order to find the direct variation equation, the easy way to do it is to do y divided by x. And that will give you the slope. So if I do 35 divided by 5, I get 7. So my equation, that's the first part, I get y equals 7x. Then it says, then find the value of y when x equals 8. So now part 2, what is y when x equals 8? I'm going to plug in 8 there, and I'm going to get 56. Okay, so there's 2 parts to this problem. One is finding the slope, or that m value, and you find that by doing y divided by x. Then you plug in a number, whatever number it tells you, 8, for x, and evaluate to find y. Okay, same thing here. It says suppose y varies directly with x. y equals 10 and x equals negative 2. So immediately I'm just going to do 10 divided by negative 2, which is negative 5. So my direct variation equation is y equals negative 5x. Then I have to find the value of y when x equals 8. So y equals negative 5 times 8. I get y equals negative 40. And that's it for that. Okay? Next part is graphing. I think graphing these are probably the easiest because you know the starting point is always at 0. Your y-intercept is 0. Okay, so that's the first thing you can graph. And then this one is a negative 3 over 1. So I'm going to go down 3 and over 1. If I wanted to keep going, I could draw more points. But again, you only need 3 points to make a line. Right? I could keep going, but you don't need to. Then I'm going to connect it. Okay, so that's how you graph a direct variation. Graph the y-intercept at 0, then follow the slope to find the next point. Remember, the numerator tells you how far to go up or down, and the denominator tells you how far to go to the right. We'll skip that one. Okay, so here's just a word problem that's related to it. It says the equation P equals 6s relates the perimeter of P of a regular hexagon to the length of a side S. Determine if there is a constant of variation. So, constant of variation is another word for slope. I don't know why there's so many different words, but this is what they're asking for. They're telling you to find the slope or the m. Okay? It says, if so, explain what it represents in this situation. So using this equation, we know that the slope is 6. So yes, the constant of variation is 6. So we would write that. And then it says, if so, explain what it represents in this situation. Well, this is a hexagon. So the 6 relates to the number of sides. The cost of bulk peanuts varies directly with the weight of the peanuts. At a local grocery store, 2 pounds of peanuts cost $5.80. Write and solve an equation to find out how much 5 pounds of peanuts would cost. So we can use the direct variation equation. Y equals mx. And we can plug in. Think about it. This is the total cost, $5.80. That's going to go at the end. We take the pound, the number of pounds, multiply it by the price per pound, and we'll get the total cost. Usually the total cost goes at the end, so we're going to plug in $5.80 for y and 2 for x. And calculator. I need a calculator. Okay, so in order to get m, I know I could do this in my head, but I'm going to need it for the other part. So m equals 290. If I plug this into the equation, we get y equals 290 times x. So that's my equation. That means each pound costs $2.90. If I want to find out how much 5 pounds of peanuts would cost, I would do y equals 290 times 5, and I would get $14.50. And that would be my final answer. So I have my equation, write and solve an equation to find out how much 5 pounds of peanuts would cost. Yep, that's it.